loves, welcome back. Let's take a look at decomposing fractions when you have non-repeated irreducible quadratic factors. And to give you an example of a reducible versus an irreducible quadratic factor, here is a reducible quadratic factor. It's quadratic because it's got a squared term, but I could break it into two linear terms. I could reduce it, if you will, because it's a difference of squares. Versus if I had something like x squared plus 4, right? This is also quadratic because of this squared, but a sum of squares is prime. I cannot reduce that. I cannot break that down further into linear factors. So when you have a fraction and you want to decompose it, you want to do the partial fractions, but you have a non-repeated, irreducible quadratic factor, right? And the degree in the numerator is still smaller than the degree in the denominator. Then the fractions you set up, what you do is for every irreducible quadratic factor, right? You put one, you represent that factor with a fraction, right? You put that factor on the denominator, and because it's going to be a squared term, you can see this is x squared here, right? Then you put a linear equation or a linear expression up on the numerator. It's always 1 degree less. So if this is a quadratic expression, linear expression. And you do that for as many non-repeated irreducible quadratic factors as you may or may not have. So let's play this out, right? These formulas might look scary, but really the gist of it is quadratic expression, linear expression, right? And coefficients on the quadratic linear constant term, coefficients on the linear constant term, right? Okay, so let's scooch this up and we're gonna get going with example 5. So if we take a look at this, we've got non-repeating quadratic factors. I do have a linear factor here, right? I have x minus 1, but I also have a sum of squares here. So I have a linear factor in that x to the 1, right? Quadratic factor x squared. So I'm going to use all of the techniques that we went over in the previous examples, but I'm going to add this stuff that was just up here, right? If I were to scroll back down, or I can't scroll, if I was to push my paper back down, I'm going to use all of this stuff right up here. All right, and we're gonna break this fraction down. So how I start this out is I'm gonna take a look at 5x squared minus 6x plus 7. And I have that denominator. I have my linear factor of x minus 1, my quadratic factor of x squared plus 1. So for my linear factor, right, a constant goes up top. Right, and for my quadratic factor of x squared plus 1, and I want to have a fraction for each of those factors, if this is quadratic on the denominator, I'm going to need a linear expression on the numerator. And I've already used the letter A, so I'm just going to forward those along. We usually just keep going along in the alphabet, so A, B, C, D, so on and so forth. And again, I have an equation now, and I've got fractions in it, and if I want to get rid of the fractions, I'm going to multiply everything by the LCD, and the LCD is x minus 1, x squared plus 1. Oops, that's a bad looking parentheses. So I'm going to take that LCD and I'm going to multiply it to the left side of the equation and the right side of my equation, and when I multiply it to the right side, I'm going to distribute that to both terms. All right, so let me go ahead and start writing this, and just because I know I'm going to need space, I'm going to write this kind of small here because we're going to pretty soon cancel some stuff. So here I am multiplying my LCD to the left side of my equation. Right? And then I'm also going to multiply it to the right side, and I'm really going to try and squish this in because I think I'm going to run out of space. All right, we got a over x minus 1. And then I have x minus 1, x squared plus 1. Oh, it's so tiny. You might have to zoom in on the video to see it. Okay, can I get that in our view screen? It looks like I can. All right. So then the same thing tends to happen as it had in previous problems. A bunch of canceling is going to happen, right? So x minus 1 divides out with x minus 1 to reduce to 1. X squared plus 1, x squared plus 1. X minus 1, x minus 1, x squared plus 1, x squared plus 1. So I'm going to see what survives, and then we're going to look at our two methods, right? Two methods being where I line up quadratic and quadratic terms, linear terms, constant, set up a system of equations. And then the other version where I plug in x values and I solve for a, b, and c. So let's take a look. If I look at my next part, right? My left side is just 5x squared plus 6x, excuse me, minus 6x plus 7. Then I have a times x squared plus 1 here. And then I have x minus 1 times bx plus c. And what I'm going to do, because I'm going to go with the setting quadratic to quadratic, I'm going to set up my system of equations is what I'm about to say. I'm going to FOIL this out. So if I FOIL this out, if I expand it a little, right, I'm going to have ax squared plus a. I'm also going to distribute here. This is going to be bx squared, right? First outer is cx, inner is minus bx, and then last is minus c. So let's do this where I set up a system of equations. So I've got a 5x squared, an ax squared, and a bx squared. So 5 has to equal a plus b. I'll keep that in mind. All right, and then let's look at the linears. So I got negative 6x. Let's see, I have a cx, and I have a minus bx. So then negative 6 has to equal, and I'm going to put negative b plus c. You could write c minus b. I just like to, sometimes I like to leave them in alphabetical order, just a personal preference. And then last I have 7 here. I have a and I have minus c. So 7 is going to be equal to a minus c. So now I have a system of 3 equations, 3 unknowns. So what I'm going to do is I'm going to solve this equation for b, so I get b just in terms of a. I'm going to solve this equation for c, so I get c just in terms of a, and I'm going to substitute them into the second equation. And I'm opting to use substitution. You can use elimination, you can use whatever you want. And again, if you don't like this method, this whole system of equations, I'm also going to show it to you where I plug in for certain values of x. All right, so we'll try it the other way. There's a second method, and we'll just see which one you like more. All right, so let's see what we have here. If I solve for b here, b would be, if I move the a over, right, if I were, and I'm just going to kind of pencil this in, if I were to subtract a from both sides, I'm going to get b is equal to 5 minus a here. And on this one, if I was to solve for c, I would move the c over and the 7 over, right? So if I isolate c in that equation, I'm going to get c is equal to a minus 7, right? So I would essentially add c, I would add c from the right to the left side, and I would subtract 7 from the left to the right side. But what I'm going to do is now I'm going to substitute, instead of a negative b and a positive c here, I'm going to put in for b 5 minus a, in for c a minus 7. And what that's going to do is that's going to give me one equation with the letter a. So let me go ahead and start writing this over here. I'll put a little separation so we can see it. So if I have, and I'll put this here, if I have negative b plus c is equal to negative 6. All right, instead of b, I'm going to write 5 minus a. But because that's a binomial, I'm going to protect it with parentheses, right? C, because it's a plus sign, I don't have to worry about the parentheses. But that minus sign needs to be distributed to both terms. And now you can see I have an equation with just a in it. So if I start to look at this, this is what? Negative 5, negative a is plus a minus 7 equaling negative 6. All right, so I have 2a here. Negative 5 minus 7 is negative 12 equaling negative 6. When I add 12 to both sides, right, if I move that 12 over, I'm looking at negative 6 plus 12 is going to be positive 6. And then when I divide both sides by 2, I get a equaling 3. So there is one of my letters. And at this point, I can substitute this a value of 3 back into the equation for b and back into the equation for c. So let me go ahead and say, now that I know a is 3, right, we'll have b equaling 5 minus 3, which is 2. All right, so I'm going to put here b is 2, keep that in mind, right? And then with c is going to equal, a was 3, 3 minus 7, which is negative 4, right? So c is negative 4. All right, so with all of those letters solved for, right, I'm going to put a 3 in this position, right? 3 is going to go with the a. Instead of b here, I'm going to write 2. So this is not 2. 2. Sorry, I was looking at the wrong letter. 2x and then minus 4. So just to save myself some space, because I still want to do finding these a, b, and c's the other way. All right, I'm going to do 3. This is 3 over x minus 1 plus, okay, bx plus c will be 2x minus 4 over x squared plus 1. And just looking at it, the most I could do if I wanted to was factor out a 2 from that numerator. So let me just give you an alternate way. You could have written this as 3 over x minus 1 plus 2 over x minus 2 times x squared plus 1. You don't have to do this. I just wanted you to see that those are equivalent, okay? So I'm going to scooch this up again, and let's try and find our a, b, and c values using the other method where we plug in certain x values. All right, and I haven't actually tried this before right now on this particular problem, so I don't know if this is faster or not, but we're going to try it. All right, so I'm going to stop. I'm going to go with this equation, right, before I do all the distribution and FOILing. And I'm going to pick x values. So the first one I'm going to pick is I'm going to let x equal 1. And the reason I let x equal 1 is because that's going to zero out this term here. And then I'm going to see what this is equal to. So if I let x equal 1, I have 5 minus 6, which is negative 1. Negative 1 plus 7 is 6, right? If x is 1, this is going to cancel out because 1 minus 1 is 0, and 0 times anything is 0. If x is 1, 1 squared is 1. 1 plus 1 is 2, so this is going to be equal to 2a. And when I divide both sides by 2, I am going to get a equaling 3. So that is consistent with the work I got over here. And I would argue it's probably a little bit faster. And for me personally, the next thing I'm going to do is I'm going to let x equal 0. Right? I can pick any x values, and I like to pick, I would call them the simpler ones. I tend to always pick 0 and 1 because a lot of things just get nicer when your letters are zeros and ones. All right, if x is 0 on the left side here, I'm going to get 7. If x is 0, what do we have? 0 squared plus 1, which is 1. So I ultimately just have an a over here. All right, if x is 0, 0 minus 1 is negative 1. If x is 0, so this factor right here becomes negative 1. If x is 0, bx is 0, and you just get a c over here. So this is negative 1 times c. So this becomes a minus c. If I substitute in my most recent a value, we'll have 7 equaling 3 minus c. And if I solve for c, right, if I move the 3 over, I would get negative c equaling 4. But that's going to tell me ultimately that c is negative 4. Right? And that's, again, that's consistent with what I got up top. And at this point, it does feel a little faster. And it's up to you what other value you want to put in. There's not any obvious choice based on these factors. Oops, let me erase my little negative 1 and c. So what I'm going to do is I'm actually going to try negative 1. All right? And so that I don't run out of space, let me try it over here. I could pick any x value, but I'm going to try negative 1. I definitely want to pick, for me, smaller numbers so it doesn't get too crazy. All right, here we go. Negative 1 squared is positive 1. 1 times 5 is 5. Negative 6 times negative 1 is positive 6. And then I have this positive 7. So 5 plus 6 plus 7 is 18 on the left side. All right. Negative 1 squared is 1. 1 plus 1 is 2. A times 2 is 2a. Okay. And then let's do this. Negative 1 minus 1 here is negative 2. All right, that's that parentheses. This would be negative b plus c. So I'm actually just going to write that out, that this is minus 2 times, negative b plus c. And then what I'm going to do is I'm going to plug in my a and c values. So I have 18 equaling 2 times 3. This is going to be negative 2 times negative b is positive 2b. Negative 2 times c is negative 2c. All right, so I have 18. Let me make sure you can still see this. Yeah, just barely. 18 equaling 6 plus 2b. All right, negative 2 times c. Negative 2 times negative 4 is positive 8. So I've got a 14 here. And just so we don't run out of space, right, I have 18 equaling 14 plus 2b. And I think you can still see that. Yeah. I'll move the 14 over. That would give me 4 equaling 2b. And if I go, I'm going to go this way now, that would tell me that b was equal to 2, right? And that is also consistent with what we got up top. So this is just an alternate way to do that, where you just plug in x values. And I try and be strategic. Initially, I try and think of x values that would zero out any factors, which is why I was definitely going to pick 1 here. And then I always try 0, and then I go -1. And if these numbers didn't solve my equations, I would try 2 and -2. All right, hope that helps. Thanks so much. Bye.